Let me recollect the things for 2 minutes. Basically, I should have concentrated on mainly in cap theorem, which is very important in architecture level and project level. We have discussed consistency, right? Consistency, availability, partition. Okay, partition. So these are the three important things. So if you take any database, you can get only two: either CA, consistency availability; CP, consistency partition; AP, availability and partition. Sorry. Yeah, sorry, Arif. Yeah. So basically in cap theorem we have. Is it fine now? Are you able to see? I forgot to share it. Yeah. So in cap theorem we have consistency, availability, partition. So any database you can check, only these three things are there. Okay. So maybe third one also there, but not 100%. But two will be 100%. Okay, so that's the reason yesterday, as per yesterday examples like a flight reservation example and Flipkart booking the pen drive example will give you more, I think it has given more clarity, right? Okay, so they're also in just now. Okay, so did you have any doubts on this, Rahman, Ramkoti, Arif? So is it clear? All these three. Hi, Sudhir. Yeah, okay, fine. Thank you. So now today another half an hour I'm going to discuss about the conceptual part of what exactly big table is comes under, what is the Cassandra, what is HBase and all these things. So when you compare with other database, then you will get more clarity on the this database as well as you will get knowledge on other databases, right? So let me open again cap theorem here once. In cap theorem you can see there are multiple examples are there, or else let me open the where is it, Hadoop and Cassandra PPTs. These are the little older one, don't worry about it. Guys, do you remember these things, the categories of NoSQL types, right? Okay, there are four categories, right? Basically, key value, column, document, graph, and a multi-tenant or multi-model. Different types are there. But nowadays, most of the industry is using column-oriented database and a document-oriented database. Key value also using, but in between two databases also we can use key value. Key value will be very less, and learning also very easy and usage also very easy, because of key value will not store a huge amount of it will store huge number of records but not huge amount of data. The columns will be only key and value, that's it, right? But in the column store databases will be used in mostly in IoT area and internet of things and the big data, as well as integrating the different systems. So mostly you are using column oriented data. So you can take first place is column oriented, second place is document, third place is key value. Graph store are very less. Only few companies may be required, which mostly into the social media and LinkedIn, Facebook, Twitter, these kind of things. Database are using these. Okay, and the companies, bigger companies like eBay, Amazon, Macy's, these companies are using multiple NoSQL databases in a single client based on the requirement. Okay, so and we discussed, do you remember we discussed yeah, there are a number of databases are there. How can we select a database, which is very difficult, right? The selecting database, because of we already I have shown you this. Again I would like to show you. Here you can see NoSQL database.org. There are 225 databases are there. So how will you decide which database is good? You can't decide simply by looking into the brief introduction of the database or features, right? So first, let's decide the what category of database you want. Okay, already we discussed. I think, is it clear, right, everyone? I'm not spending much time on this. Just I'm giving you overview or recollecting the things. Or else, if you have any doubts, I will explain little in depth. Okay, before discussing the database, and again the discussing about or comparing with CAP theorem, first we need to decide what kind of database you want to implement. Is it related, you are looking for scalability and speed, or you are looking for query navigation and complexity performance related one, or both? Based on that, if you want to only scalable and speed, key values are very good, very good speed, because of only key and value. Even billions of records are there. If you pass a key within the fraction of seconds, you will get the result, you will get the answer. Okay, like that. So if you want to get only complex and these kind of things, you can go for a graph databases. Okay, nodes and interconnections, and these things will be there here. First one, second one, shortest path algorithm, these kind of things will be there. So basically the this is very good. Yeah, database choose the rules. Yeah, basically these are not a rules, but while deciding the database, we can consider. Let's take an example, Ramkoti. You are creating a new application in our office. So you wanted to use one NoSQL database. Maybe as you are a experienced guy, so you may be interact with, or you may be include with architectural team or the initial discussions team. At this point of time, you should know what kind of this database is good. So simply you cannot say which is good, which is not good. Okay, first you need to decide what category of database you want. You want to use column oriented database, you want to use document store. Okay, and you want to use key value. See how many are there under key value. There are many databases are there. And or else you want to use graph databases. Got it? So these kind of n number of databases are there. So first you need to decide which database you want to use. Okay, which category of database. So this landscape will give you more clarity. So if your application looks requires more speed and scalability, better to use these databases. And if you are looking for complexity, go for this one. Suppose in your application both are required, somewhere the complexity query navigation is required, at that time you can use this one and you can use this one. Both you can integrate by using some middleware. Okay, don't think in depth of the in that way, just to think in a simple way. So right now, see, you can see the column oriented databases are giving almost 90 to 100% of the speed and scalability, as well as it is giving 50% of the query navigation complexity. So that is the reason most of the companies are choosing these things. See, Bigtable is there, okay, which is from Google. The Cassandra is there, HBase is there, Hypertable is there. Got it? All these are comes under column oriented databases. Okay. So as of now, let's take, I wanted to use column oriented database. I want to more speed and scalability, and a little bit of query navigation also required. Complexity is there. So I wanted to use this one. This is the point of whether here it's 50% covering, it's almost 80, 90, 100% covering. Okay. So after that, then I have decided column oriented. In column oriented, how many databases are there? See, there are almost 20 to 30 20 databases are there approximately. Some of the databases are not listed here. Google Bigtable is also not listed here. Okay. So we have a HBase is there, we have a Cassandra there. So HBase is also good, Cassandra is good, Bigtable is good. So how can I decide again? In this situation, I can come to the CAP theorem for the conclusion. Okay, I can come to CAP theorem for the more conclusion. Where is it? Yeah, Cassandra. So in the next slide, you can see already we discussed, right? CAP theorem is a consistency, availability, partition tolerance. If you want to take any database, it can satisfy only two. No database can be here. It's not possible. So all RDBMS databases are consistency and availability. Partition tolerance is not there. But if you see IBM DB2 Oracle databases are also having partition technique because of these companies are implemented by adding the extra features, by adding the extra techniques to the existing database, existing RDBMS, by providing the security, parallel processing, and partition technique. Then they have released their own product called DB2 Oracle like that. Okay, by default the partition is not there, they have included. Fine. So if you see the CouchDB, Cassandra, Dynamo, React, these are comes under availability partition. So some of the databases like MongoDB, HBase, Redis are comes under consistency and partition. Okay, now you need to decide which category you want. As per yesterday example, you want more consistency and availability, or availability partition, or consistency partition. What do you want? Okay, most of the big data related projects and a huge amount of data IoT related projects are looking for partition technique mandatory. Along with partition, what do you want? Availability or consistency? So my application is related to uh, airlines ticket booking. Then 100% I need to go to consistency. Availability maybe I can add later, but consistency is required. So then I can go for big table. See, right? Or else I can go for MongoDB. So, what kind of category we have decided? Can you tell me, anyone? In the previous slide, what kind of database category of database? Four categories, right? Column, key value, document, graph. We decided now want to use column oriented, right? Are you able to understand? Yes, right. Yeah. So when we are going to use column, so here CP. So I wanted to use MongoDB. Is MongoDB is what kind of category? You can see the color here. MongoDB is the document oriented. So here column oriented is this color. So you can check all these three are belongs to column oriented. Now I want consistency and partition, column oriented. When you decide, now you can see there are three databases are there, maybe three or five. Okay, then you can check the performance and the features and the security, enterprise editions are available, in the production support is available. Based on that you can choose data point of those are commonly used when you decide any SQL database. Same way here also, what are the things you need to go for? Whether production support is there, security is there, and implementation is easy or hard. Those kind of things you need to check. So if you are looking for high availability partition, you can go for Cassandra. Okay, the market mainly the people are using Cassandra or HBase. HBase or Bigtable, both are almost same. HBase is a completely open source, but Bigtable is from Google. It's a open source one from Apache. Okay, Cassandra is also open source, but nowadays one of the company is using this Cassandra as a enterprise edition. They're making it as a commercial one, but by adding a number of features. Okay, got it. So here Bigtable and HBase are consistency and partition is there. What is missing here? Yeah, this is a commonly asked question. Bigtable is what is missing in CAP theorem. Availability is missing. Why availability is missing? Okay, because of these are the master slave architectures. HBase Bigtable is the master slave architecture. It will be like this. We have a master, we have a slaves. So this is the data. So whatever the requests are coming, it will be received by master. These are the slaves, right? slave 1, slave 2, like that. Slave in the, how many slaves it can be, and number of, based on data. This is the parallelism and a distributed architecture, right? So when due to some reason, suppose if it is down, then database will not be available. That is the reason this is missing availability. Only consistency and partition is there. Okay, so under this we have a two databases called HBase, Bigtable. Okay, and we have one more called availability and partition. Under availability and partition, what are the things? And I'm taking only column oriented databases. I'm not talking about other databases, right? Only column, this color only. Okay, here we have a Cassandra, right? We have a, let me put in notepad, the name will be clear. Cassandra is more popular nowadays. Okay, why Cassandra is how it will give availability. So as we discussed, this is the master machine. If the master machine is down, entire slaves will not be worked out. Okay, but consistency will be there all the time. Enter all the replicated parts. So maybe some one record is here and the same record is replicated here. Every time this will be checking 100%, then only it will respond to the master. Master will check all are in the same timestamp or a different timestamp. Suppose this is updated and recently the 2 tickets are booked, but this is not updated, then it will not take. Master will take only this data and they will give. That means consistency 100% will maintain. Right? In Cassandra, the architecture will be completely different. That is called Cassandra will maintain a not a master slave. It's a ring architecture, which is very new and a very popular architecture right now. Like this, the systems are maybe 4 or 5 machines will be connected, peer-to-peer communication. Okay, all these things will be connected like in a ring architecture. And this machine will be connected here, this machine will be connected here, this will be connected here, in the peer-to-peer architecture. You're also connecting all the machines, okay, but in the dedicated here like this, but here all are communicating peer-to-peer. Okay, network may be like this, but communicating peer-to-peer. This machine should know about all the 4 machines. All 4 machines will ping, which can be called as a gossip protocol. Will be maintaining in Cassandra architecture. Gossip protocol will ping to every second. It will ping and it will ask, hey, what is the update? What is the update, like that? Okay, so this is completely ring architecture. So there is no master, there is no slave here. Every machine will treat as a master. What will be there in master? Basically, in generally, in the master machine, it will maintain the metadata, right? Metadata, metastore. Metadata will have, what is metadata? Metadata is nothing but information about all these slave machines. Maybe 100 machines are there. All 100 machines information will be here. So when any request is coming, master machine will check the metadata. So this particular information will be stored in machine 58, suppose. So then the request will be sent from here to here, and it will take the process the data and take the data, and it will respond to the client. This database, right? So store the data, read the data, write the data. The same way ring architecture. In the ring architecture, it will store everything. That's, yeah, metadata will be stored in all the machines, not only one machine. Every machine will have a metadata. Metadata will not occupy much memory, right? Just information. So this machine should know what kind of data is available in all the machines in the metadata of this machine. In the all the gossip protocols, it will update the metadata every time. Okay, so and the other advantage is, if any request is coming, it should reach only master. If the master is busy, this request will be waiting. But here, no worries. Request can come to this machine, and request can come to this machine or this machine, because of all the machines are like masters, right? So any request can received by any machine. Suppose when this machine is received request, it will check whether data is available in the same machine or not. If it's not, it will check where exactly it is available. Suppose this is available in this machine. Internally, it will send a request to this machine, please give the data. So this machine will give the data to this machine, then it will send the response. See, even if there is no data, but it will take a responsibility of this request. Getting? This is can be called as a coordinator node for this particular request. Each request, the coordinator node will be different. Okay, this is a very popular architecture now in the NoSQL area. So if due to some reasons this machine down, due to some reason this machine is down. Do you remember replication is mandatory in the distributed architecture? Whatever the data is storing, 100% it will store in 3 different nodes. That's it. No worry about, no second thought on this. It may be 5, it may be 10. You can choose, but minimum 3 replication is almost there in all the databases and distributed architectures. When this is a down, you can see we have a ring like this, right? We have a ring. Again, this is down. We have a ring. Again, this is down. We have a ring. Again, this is also down. Still, we have a machine. This is also down. Then you should not expect any high availability when all the machines are down. Okay, here only one machine down, entire database will be not available. But here, even one machine is available out of 100, still you can get some data. This is called ring architecture from Cassandra. Okay, so what is missing in Cassandra? Can anybody type? What is missing in Cassandra? No, as per CAP theorem. Performance is again very good, Rahman. As per CAP theorem, we have 100% available, right? Even one machine is down, we have availability. Another machine down, we have available system. Yeah, no. Partition tolerance will be 100% there. Consistency is missing, right? See, A and P is there. Exactly. Consistency is missing. How it is missing consistency? Let me take new one. In Cassandra database, we have like this. There are 5-10 machines are there. Okay, all are connected, right? So each data will store in all the machines, right? Each data set is stored. Suppose I have a table, I have a record stored here, and it is stored here, and it is stored here. So when I get a request to this machine, okay, so I would like to know the data for 101 employee, what is the salary of employee. So it will read this data and it will send to the response directly. It will not check whether this data is correct or not with this machine and this machine. That is the consistency. When it checks from here and again it is checked from here, when both are okay, then it will read it from here. Suppose the request is coming to other machine. Let's take request is coming to here, but data is available in this machine, in this machine, in this machine, not here. Then this machine should check with the whether the give some data, give the data to this machine, and give the data to this machine. All three will give. Which one is recent? It will verify and it will send. Then that means it's 100% consistency. But when there is no consistency, performance will be improved again. Please remember this point. When consistency is not required, performance will be very good, because of when anybody send a request to get some data, it will ask 3 machines. Okay, and it will not, we are not worried about consistency. Any machine is send respond, immediately it will send respond to the client. It will not wait for all 3 machines. If you are maintaining 100% consistency, this machine needs to wait to get the result from machine A, result from machine B, and result from machine D also. Then only the E machine will send the response to the client, which will take time. maybe by that time B machine may be little busy, or it may not be send the response properly due to some network bandwidth issues. It's not responding properly. Still, the client should wait for getting the response. If consistency is not required, simply any one machine is response, that's fine. It will send the response. That means the Cassandra is very high performance database. Okay, but consistency is missing. That is the one negative point. But this is taken or updated, or this feature is added by a company called DataStax. DataStax is a company which is taken by I mean Cassandra open source, right? The DataStax is working with the Cassandra, open source Cassandra, and they become they make it as a commercial one, enterprise edition. Okay, so we are not going to discuss much about Cassandra. Just I wanted to give these details. You can check here, datastacks.com. This company, when the Cassandra is taken care by this DataStax company, Cassandra is very popular. Okay. Consistency. Here you can see nowadays they are providing all kind of things. Many customers are there. They are focusing on IoT, big data integration, all these things. Okay, even you can, if you want, if you're really interested, you can learn with free of cost by going to the academy. I'll give you that one, DataStax Academy. Where is it? The DataStax itself, you can. Yeah, here you can learn completely free of cost. Yeah, I have learned from the DataStax website only. In 2015 we have done a project also in DataStax Cassandra. Okay, here you can see, yeah, take our free online course. You can get started here, and you can register yourself. You can learn it. Okay, 100% added advantage along with the GCP. Anyway, as part of GCP, we are just learning big table also, right? But along with that, if you know Cassandra, 100% it will be added advantage. Okay, you need not download DataStax and other things. Just try to learn and understand the Cassandra, how to just to try to practice something. Okay, this is one. HBase, HBase is little difficult because of still it's open source. Nobody is taking care about HBase, and it's a development and the writing code is little complexity. But DataStax is made it simplified the Cassandra. Okay, good. So these are the main architectural differences. So here Cassandra is missing consistency, but this company called DataStax is providing consistency externally. External, which can be called as a tunable consistency. They are making it as a tunable consistency. Okay, here Bigtable and HBase missing with consistency partition is there, missing with availability is missing, right? For this, the Google is providing availability for the Bigtable, and for HBase Hadoop is providing availability for the HBase. Third one also there, completely not zero. They're providing, other third party vendor needs to take care about it. So all these databases are good at CAP level now, but while choosing 100% the by birth, what is the CAP theorem, within the CAP theorem, what is the features are available, we need to consider while deciding the database. Understood? Is it useful for you? It's conceptual wise, architectural wise. Okay, please remember CAP theorem. Please try to spend some time on CAP theorem and Cassandra and big table HBase. Please try to get some differences a bit among these three. Okay, and you can use in Google. You can check the differences in the performance level, differences between, not between, difference Cassandra, HBase, big table. You can go to images. You can see some of the differences are there in performance level. It's a very old one, so just you can get some information from this. Okay, Cassandra, Couchbase, HBase, MongoDB. Read and write inserts. See, Cassandra, always Cassandra is good, right? Here you can see. Read heavily, and the balanced also very good. Inserts also very good when you're comparing with HBase. MongoDB is also, sorry, Bigtable also like HBase only. What are the figure? Okay, see, these are the different things. So again, here Cassandra, or this is very good in performance level. Okay, so I would like to stop here. I need to go to office little early now. So okay, so just spend the time on these things. So in the long weekend, once we back from the vacations, Sankranti vacation, so we can start. We can do some practice in GCP itself. Okay, big table, and then we can start with the BigQuery. At the time of BigQuery, I will explain the Hadoop related concepts. So what is Hive, what is Pig, and HDFS. Those concepts required. How we discuss like this. We discuss Hadoop and big data concepts. So when we are discussing PubSub and BigQuery. Okay, guys.